Right, it's 6 minutes past 9. So, great. Okay, Brennan, gonna start. Get the speaker notes up. That's my mouse. That's a good way of doing it. Okay, we'll bear that. Right, hi. We're gonna start. It's 7:05, so we're almost on time. Okay, hello and welcome to the July edition of the DigitalOcean Amsterdam Meetup here at the Your Majesty office. I'm David, the guy that sends you all the emails and makes you get inside when it's really nice and sunny. Hopefully you managed to find a seat, which looks kind of promising. And yeah, let's go for the formalities. Toilets are behind you if you haven't found them already. If you smoke and vape, you got to go downstairs, outside. We don't mind. It's all there. We got a table of stickers finally. I did get around to those eventually. They're just over there. We got lots of stickers from more or less everybody. And we got batteries from Bolt.com, which is really cool. Yep, so that's all over there. Yeah, if you've got your own stickers and you're in the audience, you can still bring them along and happily contribute. That's always good. Does my thing work? Yes. Right, so I need to thank a few people who helped make this possible because I can't do it all on my own. Doing stuff like setting out chairs, checking you in, doing the live stream stuff. Sharon couldn't make it this month. That's what Sharon looks like. So she normally does the name badges at the front, so that's why it's maybe a little chaotic. So there's me instead trying to do that one as well. Yeah, I'm leaping over fields of lavender there, which is what I do in the weekends. Hugo is running the live stream and checking people in. He's a very talented fellow. And here is a ravaging photo of him. Hugo and I will be floating around all evening. If you've got any questions, you can ask either of us or maybe one of the YM team, but there aren't many of us here tonight, but you'll find us. And yeah, thank you for turning up. It's really appreciated. It was meant to be thunder and lightning and miserable and rainy, which is what I want. And it turned out to be really sunny and 30 degrees. So that's really annoying. But yeah, you guys are inside and that's appreciated. Tonight's agenda. You found your seat. This is the introduction. Maurice from Bol.com is going to give us a chat about resilience engineering in the microservice landscape. And then, yeah, then there's a brief interlude. You get like another beer. I've got loads of beers. And you can go for a toilet break. And then Stuart, he's here somewhere. I think you can't have an S and a J in the English language. Yeah, I tried. Yeah, they're coming from a grocery perspective, talking about Mesoservice architecture. Daniel might turn up, maybe, if he hasn't died.
He may or may not.
Maybe.
He's the most mysterious character.
He's very mysterious. He could be sunbathing. So yeah, 2 talks, and then after that, pizzas turn up, and you can grab pizza, fight for pizza, and grab a beer and chat about stuff. So that's the plan. We've got more house things to do. So emergencies. In the event of a fire, I really hope this doesn't happen. There's like a fire exit behind you by the toilets. You jump over all the mops and the beer crates and stuff, and you run down the stairs. If you don't want to jump over beer crates, you've got to go down these stairs where you came in, and you kind of congregate on the bridge. Yeah, and we'll sort out the rest. Yeah, if you hurt yourself fighting over beer or pizza, you find either Hugo or I will give you paracetamol, and hopefully it's not more serious than that. And if it is, we can call an ambulance, but hopefully you won't need that either. So it's that, and yeah, so we've got it covered. Don't panic. We have a very official code of conduct, which is here to outline how everyone should behave, and the protocols are in place. If there is an incident, it's good practice. Lots of conferences have it, so we have one too. So yeah, DigitalOcean is dedicated to providing a harassment-free event experience for everyone, regardless of gender, gender identity and expression, sexual orientation, disability, physical appearance, body size, race, ethnicity, religion or lack thereof, or technology choices. There is more there. If you want to look at the whole version, it's on the internet. But just generally, just be nice to each other, and then it'll be fine. That's the general gist. Nobody left this time, which is great. Last time we had one person that just like upped and left at this point, which is just like impressive. If there is an incident, you didn't get enough pizza or something, you can find me and we'll talk it through, or you can send an email or a tweet after the event. If you want to take it further, there's a lady called Samantha. She manages DigitalOcean meetups globally, and all details for all of these things will be on the last slide. Yeah, and if you want to tweet, you can do DO Meetup, and I will find it and I will like it. Yeah, and then, so yeah, there's a few sponsors. Your Majesty provided the office. DigitalOcean bought all the beers, the tote bags, pizzas, all the things. So it's kind of important, these guys. DigitalOcean, if you didn't know, they are the first cloud hosting provider to use all solid-state drives everywhere. You can create a droplet in a record 55 seconds, and it gives you full root access. It really is the bee's knees. So it's all super simple. You spend less time throwing your computer across the room and wondering how a server works, and more time doing the stuff you love, which is coding, hopefully. I updated all the GIFs like this month so that people who've seen it like for the past like 6 months have something new to look at. Also, DigitalOcean, they also rolled out a new service called Object Storage. They can't tell you the name or what it looks like, but if you sign up before the 31st of October, you get a free terabyte of storage up until the 31st of October. So that's very exciting. You should go and check it out. Your Majesty, this is their office. We do design things for like Netflix, Adidas, Samsung, Spotify. There's more. Yeah, we have a funky logo we did recently. And yes, so some examples of stuff we do. We do NMD, which are shoes, and we put them on the side of massive cubes and scattered them across Europe. And this is what that looks like. We also do 3D horsey games, which we win awards for in like WebGL. This is fun. You can play this on our website. We do lots of stuff for Samsung Smart Things. So this is the instructional video for all the smart TVs everywhere. We do the smartthings.com website, which is cool. And it's all totally responsive, so that's great. Gotta get rid of that joke. I've done that too many times. When we're not coding, we have parties, and most of them are Swedish. So we do Midsummer, which is just an excuse to go out and get drunk. So which is nice. Yeah, the calendar, it's looking a bit bare at the moment, and I am working through this. There will be more meetups in the future. We typically have them on the third Wednesday or Thursday of the month. They usually surround it like on topics surrounding web development, DevOps, and cloud, essentially nerdy stuff. I try and make things interesting. Next month we got Hank Steenman from Amsterdam Internet Exchange. He's going to give us a really deep dive into how the internet actually works, and I need to find somebody who's equally as nerdy to go with him. And there's more of that in just a second. Yeah, so yeah, I've sent out lots of emails this month to many people, including like Equinix, who do data centers, Google, and even Booking.com. We'll see what comes back. So there's a few things up in the air. We might have some talks in September from Intel. That'll be kind of interesting. So watch this space. There is quite a lot of space to watch, but it's all there. So yeah, this week I thought I'd send an email to Tim Berners-Lee, aka the guy who invented the World Wide Web, HTTP, and the browser, and basically gave us all jobs. I thought, that'd be really cool if we could have him in. That'd be amazing. He has a website and it's all like HTML based, so there's no like CSS or anything in there. And there's lots of documentation that you can do before contacting him. I wasn't trying to find something on the internet. I wasn't trying to figure out how to run a server, and nor was I doing any homework, so I thought I qualified to send him an email. And I was quite surprised when his speaker person representative from New York got back to me. But in short, I can't afford Tim. I'd have to remortgage my imaginary house, and just to get him here for an hour. That being said, I would be able to take him out for dinner, and that'd be super nice, but he never splits the bill, so I'm paying for that one too. But maybe one day we'll have Tim. I'll keep you posted if we ever have to abduct him or something. But yeah, if you guys have ideas or topics for speakers you want to see, just put a message on the board, or send me a tweet, or find a way of getting in contact, smoke signals, and I will chase these people down, even if they are outrageously expensive. I will chase them down and figure that out, and then be like, we can't afford them. But yes, I will try.
Do you think he'll give a talk if we just all rock up at his house?
Maybe that's the way of doing it. People have been saying like crowdfunding and stuff, but I don't know. Either way, there are more speakers to come. So that brings me to my last slide. Here is me in like a bush. That was midsummer. And my Twitter tag to get hold of me. That is what Samantha looks like from the side, and that's her hashtag to get hold of her. You can email her at samantha@digitalocean.com, and you can either say nice things like, oh my god, the pizza was great, or terrible things like, I don't know, David was very sweaty. And yeah, if you can say these on the internet as well, on Twitter or Instagram or all of the social things, but make sure you tag it with DO Meetup, otherwise I will never see them. And that is it. I have done. Does anybody have any questions? Yes, we actually have questions. Okay.
I see there are seats around there, and I see people standing in the back.
Sure. Yeah. If you guys want a proper seat, then you can sit there. It's a bit closer.
People sitting here can move in.
Yeah, either or. I mean, or you can have a really large space. It's really up to you guys. If you like perching in the back, that's fine. But there are spaces if you want to jump in. Yeah.
One more question.
One more question.
I'm really warm. I want some beer.
Go for it. So 2 beers. Okay, right. We will get you set up. First one up is Maurice from Bolt. And yeah, here we go. Let's pull that up.
So let's see if
does it work. Let's try the insert. Does the projector sound like you?
All good.
It's looking promising. Yes,
Yes.
good news. Okay, yeah. Can we have a warm welcome for Maurice?
Okay, hi, and thank you for coming to my talk. So I'm going to talk about resilience engineering, what it is, and I'm going to show you why you want to do it. So first, who am I? Because you've probably never seen me. I'm Maurice Zeijen. I've been doing Java for more than 10 years now, and currently I'm working at bol.com as a lead software architect. There I did a lot of stuff in the area of implementing resilience. And so for the ones of you who don't know what bol.com is, so bol.com is like the small Amazon of the Netherlands. We sell stuff. And we currently have about 28 million visits per month. A lot of products, 40 million of them. And a fairly amount of customers in the area of 7 million. Also, I have about 1,200 colleagues, and of them 350 are as me in the IT department. So that's about bol.com. So what I'm going to talk about, first, what is resilience and why do we need it? How do you implement resilience with the help of Hystrix, which is a Java library? Then we go into the resilience techniques that Hystrix provides for you, or what you need to do yourself if you want to do it yourself. We'll go into some tips and tricks we picked up while implementing this stuff, and then we'll look at some operational concerns and into our experiences, and then I'll wrap it up. And hopefully I can do it in 40 minutes, but we'll see. So first, what is resilience? And of course we need to look at the dictionary for that. And it's the ability of a substance or object to spring back into shape. So like you have this guy jumping from a crane with his bungee cord. It stretches really far, the cord, but when you relieve its tension, when the guy is on the ground again, then it goes back to its original shape. It's really resilient to those tensile strengths. But it can also be the capacity to recover quickly from difficulties, like if those two guys are sick, and one of them is really quickly better again, back at job, and the other one isn't, then we could say he's more resilient to that sickness. Okay. But we are here for IT systems, right? So it's the ability of a system to handle unexpected situations, and preferably without the user, which can be another system, noticing it. Or at least we get some graceful degradation, so no big error screens, whatever. And really important is that it needs to be able to recover automatically so that you don't need to restart your system when it fails. It needs to do that by itself. So that also works at night. So at bol.com we have this web shop, and it communicates with a lot of backend services, and that's the area where I'm going to talk about resilience, because resilience is really a broad topic, right? But I'm going to talk about this area here where we want to protect the web shop against all these services. Those services can fail, and we don't want the web shop to know this. Yep. So, why do we need it? Well, if you have a really complicated microservice landscape, then it starts getting complex really fast. And everything is distributed, interconnected, and in those cases, well, failures, they are simply not an exception. They are really normal. It will happen for sure, and you need to be able to deal with it. So for instance, at bol.com, we have a fairly complicated landscape with about 50 systems, user-facing systems, and about 120 backend systems, backend services, and 60 IT teams that messes with those systems all the time. So in the end, yeah, well, you can guess it's going to fail. And what can go wrong in those backend systems? Well, they could simply fail and go down, or they could put up a new version and it has a bug, or it's not backwards compatible. It could also be the network, a router that fails, or a switch. But it can also be on your side in the client library that is talking to the backend service that has a bug and it doesn't work. And the worst thing is when a service becomes slow. That's really the worst. So why is that? Well, something becoming slow, so increased latency, it's sort of a disease. It spreads, it's a sickness, and it can cascade across your whole network. And I'm going to explain you and show you why that is later on. So we simply need to be resilient, and this is an example in Texas in 2008, where this was a beautiful beach area, so with a lot of houses. And there was one house that built itself to be a little bit resilient against a storm. Well, it's a pity for the other houses. So we don't want that for our systems, right? So in my presentation, I have this interactive demo. It's actually really running on my system now. It's a sort of mini service landscape with an application. So first we have the web shop, and it has two pages, a product list page, and it talks with a client to the backend product service. We have a product detail page, and it also talks to the product service via the client, but it also talks to the review service. So keep this a little bit in mind, because it's important for the demo. And well, we have this load generator, which generates about 50 requests per second on both pages. So this is my demo web shop, and it really works. This one has a couple of nice text for you. So, okay. So what I can do in my demo is mess with one of the backend services, especially the review service. I can make it slow or create it to have bugs, so I can turn it off. We're going to see what happens to the web shop when we do that, when we have resilience, or we don't have resilience, and when we have resilience. Come on. Nope. This is not right. 1 second. Yeah. So, in this demo, I use Hystrix, and also at the bol.com we use Hystrix a lot to implement resilience. And Hystrix is a library from Netflix, which implements fault tolerance and latency protection. And it is designed to isolate those backend systems from your system. It provides the means to handle failures gracefully, and it measures about everything it can measure about those interactions. And it's relatively easy to use. And there are, if you're not a Java developer, there are alternatives for other languages out there as well. So just search for Hystrix for PHP and you will find something. Where does Hystrix live? Well, Hystrix lives in your application, so in this case in the web shop, and it sits between in this case, the product list page and before the product service client. So there's this boundary where you need to go through Hystrix before you can do your backend call. And Hystrix implements this flow with all these kinds of resilience techniques. So you don't need to remember this flow now. We'll go through it in the presentation. And to start with, it has this round trip where you execute something that's called a Hystrix command, and it will call your backend resource. Question, who has ever used Hystrix here in the audience? Or something similar? Circuit breakers? Okay, well, that's the correct audience then, I think. So it calls resource and the result is returned, you know? So how do you implement this? This is the most basic way. There are wrappers to make this a lot shorter, but this is the core way of doing it. So you have this, you create a class and you extend this Hystrix command and you tell it which return type you have. In the fields, you give it everything it needs to be able to contact that backend service. You give that deposit in via the constructor. Then you give it a name. So in this case, it's it's a group name. It's a group review, and it's the name get reviews. And in the end, the most important part is here this run method. And in this run method, you actually do what you want to do, and that's called the client with the get reviews with the product ID. Like I said, this is really the verbose version. There are shorter ways of doing this. And the important thing to remember is that you need this command for every endpoint. It's not one command for a whole service, no, for every endpoint, for every resource. And this one is blocking, this histrix command. You have also a histrix observable command if you want to do non-blocking stuff. So how do you execute it? Every time you want to execute it, you create a new command. And if you want to do it blocking, you simply say execute and you'll get the result. If you want to use futures, then you do Q and you say you get a future, and it's not a completable future, so forget about it. Then you also have the asynchronous method using RxJava 1. It's not up to par with Java 2 or with Reactor yet, but it works. It gives you an observable way. It gives you a method to deal with asynchronous results via callbacks. And the last one is where you can do streaming. So instead of getting one product, you get multiple products back, and it's similar to the previous one with the observable, but now you get the subscribe lambda is being called for every review coming in. And one important thing to note is that back pressure, because it's RxJava 1 and Histrix, it doesn't really support back pressure yet. It's a pity, but it's what it is. So what kind of techniques does it implement? Well, we go through these all now. So first, the fallback. We all know this one, right, from the past, like Windows failing really bad on you. This is not really graceful, right? It's really painful. So that's what we don't want. So what can you do? So if you have a user-facing application, then you could simply hide the feature that uses that backend service and simply do as if it doesn't exist. You could also use some default value or an alternative value. It's also a possibility. We'll take a look at that in a second. Or you don't implement a fallback at all if it doesn't make sense. And we'll look at that in a second as well. So where does this fallback stuff exist? Well, after you call the resource, Histrix will check if your execution was successful. And if it wasn't, then it will go to the fallback. If you do have a fallback, then it will execute that. And if that was successful, then we'll return the value of the fallback. It's really simple. If it wasn't successful, the fallback, or it doesn't exist, then we simply fail with the original message. So, like I said, I have a demo. It works with these kinds of graphs and these methods where I can break stuff. So what we see here on the left is the number of requests coming in for the product detail page, on the right for the list page, and here below we see a distribution of the reviews over the different kinds of products. So we see that most products have about 3 reviews. And if I now kill the service, and let me switch and show you that it actually exists. So, well, we see now that on this side for the product detail page, the error amount is really high. The other one, the product list page, doesn't use review service, doesn't really notice. So if we go to the demo shop, I can show you. We first saw that it had a couple of reviews. Well, now, well, it's too bad. It's not really what we want, right? So what I can do is I can activate my fallback, and normally you would have this active always. I can turn it off and on just for the demo purpose. And we see now that every product detail page becomes a success. However, the distribution is 0 because my fallback is an empty list. I simply say I don't have any reviews. So now I do have a product detail page, but I don't have any reviews. But I could, still buy the product if I would have that option in my shop. So another real example we have at bol.com is we have this. This is also a product list page where we show all the products. And when you browse through our shop, you go to a category. So here we're on the category laptops. And you have the possibility to filter. So here we filtered on films and series. And then we have this other service that determines what the best title and text is for that page. So it determines, oh, laptops for films and series is the best title, and we put some text next to it. So if that fails, then really simple. We just, pick the title of the category, and that's it. Oh, fine. Nobody probably notices. Cool. So, but you don't always want a fallback, and especially not for write operations. So if, let's say, I just ordered something, and it tells me your order was fine, but it really wasn't because my fallback was activated, that's not really nice. So in that case, I need to notify my user. But also if you start some backend batch service or some offline thing, then you really want to notify the one that tried to do that it didn't work. And we also noticed that in backend services, if you need to implement Hisfix there as well, it's pretty hard to decide on a decent fallback because you're not really the end user, so how do you know how to fall back? So in those cases, it's probably better to still give an answer with some data and leave out the data that you don't have, but give the meta information that it failed so that your actual client can do something with it. So how do we implement the fallback? So again, we have this Hisfix command, and we have this run method, and above we should have the fields and constructors. But now we have this extra method simply called getFallback. And in this case, I simply return an empty list. Yeah, really simple. So if you don't provide a fallback, then you still need to deal with that exception that can come up. So if I execute this, I get a Hisfix runtime exception. And in the Hisfix runtime exception, in the get cause, you will find the actual exception. So, okay. Next thing Hisfix does for you is protect you against latency, which means with that when the resource is called and the call is too slow, then it will time out. And when the timeout happens, we'll go to the fallback again. So let's demonstrate that again. I can increase my latency and I won't activate the timeout yet, and we'll see what happens. So this is again the number of requests per page, and here we see the latency for that page, for the product detail page. And you see the latency really gets high. One other thing to notice is that my thread usage, and I deliberately limited my threads for my system, but it's getting really full. All the threads are being used. And that's, 10 seconds for a page, not really what we want. My customer is not going to buy anything when it needs to wait 10 seconds. So let's introduce a fallback. And I first need to make it recover really quickly, because else we'll have to wait 10 seconds before the fallback will activate. Okay, so now let's simply say I have a fallback for half a second. And now we see the difference that, it's limited to 500 milliseconds, so half a second. But now everything is an error, which I can fix by activating my fallback. But we still see a fairly high thread usage. And when I set this thing to a second, then we still see that we're using a lot of our resources of our system. That's really bad. So, and I'm now going to show you why that's bad and what you can do against it. And what you can do against it is using bulk heading and load shedding. So if you have a ship, then it has these bulkheads, which if you implement them correctly, and not like the Titanic, it will prevent your ship from sinking when a part of your hull is ruptured. Because it prevents the water getting everywhere. So where does this fit in our diagram? Well, it's completely at the beginning. Before we actually call the resource, we have the semaphore or thread pool. And it makes sure that the resource can only be called so many times at the same time. So for instance, if I set it to 10, then when the 11th call comes in, while 10 other calls are still at this stage of calling the resource, then the 11th will be rejected. It will immediately go to the fallback. And let me demonstrate that. First, let's look at the bad situation again, and we have now even more graphs. Here the product detail page request, the product detail latency, and the amount distribution. Here the one for the product list. And remember, that one does nothing with reviews. The product list latency and the thread usage. So what happens when I increase it again? And let me make it really bad. So around 5 seconds. So, okay, this one we expected, right? But now we also see this happening. The product list page, which has nothing to do with my reviews, is also having issues. And that's because it doesn't get the resources to be able to deal with the number of requests coming in. So it's also becoming slow, and it's really becoming slow. It's becoming really terrible. And timeouts can only help me so much in this. So this is the example where the cascading effect comes in. Because not only the part that is directly affected has a problem, but everything starts having problems. So let's say we have this little service landscape with a root service and some other services that make use of it. And when the root service becomes really slow, then of course we expect everything that is directly calling it or via another service to become slow as well. That one is obvious. But we've also seen just that other parts of your system also become slow because they don't get enough connection thread pools. They start filling up. So if these become slow, then of course it will happen to everything. And if you don't have any mitigating solutions like caching or other stuff in your system and everything is directly calling your backend, then your whole cluster could fail. You do need enough requests per second coming in, right? It doesn't really happen really easily, but it can happen. So now let me introduce my bulk heading and simply say I won't allow more than 10. Let me introduce a timeout and let me make it really bad again. So, of course, we see here that the arrow page now ramps up. We see some slowness, of a second. But the product list page is totally not affected, doesn't really care, it's really fast still. But we see only 10 threads being used, and those are the 10 threads that are causing this, this little ramp up here at the end. The rest is getting the error immediately. I think I'm going to skip this one. This is the difference between threads and semaphores. I will post the slides, you can look at it later. So, all these parts in Hystrix is generating a lot of metrics, and these metrics are really useful for you as a team, but also for operations to keep an eye on your systems. And these metrics are generated from calling something else. So it's really interesting because often you don't get those metrics; you only get metrics from something getting into your system. And this is a little part of the Hystrix dashboard, and it shows us things like how many successful requests it processed, and the other numbers are for failures and different failure types. The number of total requests coming in, also over a whole cluster if you have multiple instances. But you can also see interesting latency times like the 99.5 percentile. And these metrics, they are generated by all these different parts. And they get together and they're reported. They're used inside the circuit breaker, but you can also tap on, use them in your own metric systems and do alerting on it or just metrics. So this is the Hystrix dashboard of the current Bol.com webshop. At this point, it's live. And what we see is, well, at Bol.com, like last year, we did a lot of Hystrix implementation, and these are all commands that we implemented and for all those backend calls to the backend services. So, and this overview is just to give a general overview of what's going on in the system. It's all fairly green, so I'm happy, so it's good. But we can also, this is just a snapshot from the last, I think, minute. But if we want to go deeper, then we also store all the historic data. So this is the historic data of today, but you can also look at it from last half year. And we see here, for instance, is the number of successful commands, executions, but also that failures they happen regularly. And we can look at latency numbers. Really interesting stuff. Not just for resilience, but also to blame the other guy for having a slow service. So this one we saw, yeah. So, the last thing we have in our defense is the circuit breaker. And the circuit breaker is like in your fuse box, you have a circuit. When you are messing with electricity or you have a device that fails, then you have a short circuit and it will open up and don't let any current through. That's something similar that we want for our systems as well, but we want it to automatically recover. So, where does that thing stick? It's completely at the beginning. When the system comes in, the circuit breaker looks at the resource health, and it uses all these metrics to calculate if the resource that you're calling is healthy. And if it's unhealthy, and by default it's 50% error failure, then it will open up and it will short circuit everything to the fallback. But sometimes it will let one request through to see if the backend resource is healthy again. And it works like this diagram. Like I said, when it's all healthy, then it's closed, which is really confusing to call it closed, but that's how it is. And if you have too many failures, then it will open. And sometimes it will try one request. It goes to half open. When it fails that half open state, we go back to open again. But if it's successful, we immediately close the circuit breaker and let everything through again. Okay, so why is that a good idea? Well, I'm going to show you that now. So I'm going to skip showing you what can go wrong. Well, immediately, no. Well, let me activate some circuit breaker, some timeout at least. Introduce some latency again. And I haven't activated circuit breaker yet, so it doesn't really do anything at this point. And you see here, this is circuit breaker status. It's filling up, seeing error percentage of 100%. Okay. If I activate it, then look at this part. You saw it totally shrinking. So when I deactivate it again, so the thing is, when a circuit breaker opens, we know that the thing is not healthy in the back. So why waste any resources on it? Your page will become really fast, awesome performance times, but you won't be bothering the backend service as well. And maybe because of you doing that, it can recover. It's not a guarantee, but it can help, if it's overloaded. And I can also see if we reduce a little bit, that it opens up again. Even when a certain amount is a failure, it's below 50%. So okay. So these are all the things that Hystrix does for you for resilience purposes. And I want to share some tips and tricks regarding that, about implementing it. So first, if you're doing circuit breakers or any kind of stuff, make sure you have monitoring or alerting on it. Because it would be really nasty if your customers start calling that they never see reviews because your circuit breaker is open, but you never saw it. So you should be monitoring that really actively. And at WorldCom, we make a difference between critical and non-critical systems, because some services in our web shop, it's nice that they fail. We could do a fallback, but our shop would be completely useless. Like if we don't have search, then you couldn't really do anything. So those services are critical. Other things like showing recommendations or those titles, they're not that critical. So if a critical one fails, then the operations guy in the team will get notified immediately to check what's going on. A non-critical fail just will result in a warning so that they can look at it when they have time for it. So also another thing people tend to forget is that you often have this client behind the circuit breaker and needs to be configured as well. Especially with the timeout settings, you really need to configure them. But also connection pool sizes are important, that they match your Hystrix concurrent request settings. So for that timeout, why is it important? So if you have a normal run, we have this application and it calls this Hystrix command on the application thread, or request thread, or whatever it is. And Hystrix will use threading, and it will start executing the resource at the client in a Hystrix thread. Okay, when everything's fine, everything goes back and it's cool. But if you have a timeout, then the Hystrix command will time out, but that thread will still be active because it needs to have that timeout from the client to discontinue its work. And Hystrix will try to interrupt via an interrupt that client, but clients often don't listen to interrupts and they are useless. So if you don't set up your timeouts correctly, and certainly if you're using semaphores, so semaphores execute everything, I skipped that, everything on the same thread. With semaphores, it's really bad because then you don't really get that latency management from Hystrix at all. So what can you do? You can make the resource have a shorter timeout than Hystrix has. That has the advantage that, let me think, what is the advantage? I don't know. I forgot, sorry. But,
You're not leaking connections, it's still busy when Hystrix cuts off.
Yeah, but I have another alternative, because the thing is, if the client times out, it will be registered as a normal exception. It works, but you won't see in the metrics that it's a timeout, just an exception. If you make the client just timeout after Hystrix, then Hystrix will timeout first and it will know, oh, it's a timeout. But you can also use a trick. That's what we do at bol.com, and we have Histrix is really pluggable. We created a plugin for it that will look at every exception coming in, and if it's one of the known timeout exceptions, which Histrix actually should do it by itself, but it doesn't, then we will create a Histrix timeout exception for it, and will still register as a timeout. Another thing you can do, which is really practical, and certainly if you have that other one, that hook in place, then you could pass along the timeout that you've set up for your Histrix command and pass it to the client for every request, which is really powerful because it's one setting less you need to worry about. But also, Histrix allows you to dynamically configure every command on runtime if you set it up correctly. So if you start playing around with timeouts, your client will immediately pick that up for that specific request. Only you shouldn't be doing that if you want to do retries within the Histrix command, because that can go horribly wrong. If you have too many retries, then you're actually causing the same problem as having too long of a timeout. So here we have a client with a lot of retries, and every time they time out, even when the timeout is really short. But that's all within Histrix thread, so it will still time out first, and you still have the same problem with extra load shedding and extra latency, and you're flooding the resource. So if you want to do a retry, mostly don't try more than once. That's the general advice, because if after the second one, with the second one you try to think, let's see if I can hit another node. If that other node is also having problems, then it's probably a general problem, and another retry won't fix it. So, okay. Yeah. So, naming. Every command has a name, and that name is shared everywhere. It's shared via configuration properties, but also via your metrics. So you need to have really good names. So the names need to be descriptive, like what is that command doing, and what system is it calling. But also it needs to be somewhat unique within the system. Like you saw in our web shop, we have a huge number of commands. We need to make sure that they're always unique in their naming, because else you can't configure them. And this is the pattern that we apply. It's really simple. Every service at our system has an ID. It's a really short name, like PCS for product content service. So we use that as a prefix. Then the command name is a descriptive name of what it's doing. Gets product by ID, for instance. And then if you have multiple versions of that same command in your system, then you can also optionally fix it with a version number. It's really simple, but interestingly enough, a lot of tooling around Histrix doesn't really do this. It takes the command of the class name or something, and that won't work in a scaling system with a lot of teams and operations and stuff. Really short on tuning. If you need to tune your commands, you need to set up the correct thread pool sizes, the correct timeouts. Else, if you don't set it up correctly, then it won't do anything for you, or it will fail a lot more than you want to. So you need to tune, and you need to tune based on production, because production in the end is really the truth of your system. You could use a sort of a load test to get a feeling of what it should be, but in the end, the production numbers should be telltale. And you should be basing that timeout settings on the behavior of the resource that you're calling when it's healthy, not on the timeout that you want it to be. Because let's say I'm calling some resource that normally takes a second in its 99th percentile, and that's just fine. If I want it to be 500 milliseconds, I will see a lot of failures, but it's not really because that resource is not healthy. It's because I am not doing my timeout management correctly, because I would need an extra timeout that wouldn't say it's unhealthy, the resource that I'm calling. And if you've tuned something, this is a general advice. Don't keep on tuning, just tune when it starts acting up. And don't forget to tune those timeouts on those clients. I'm going to skip this one. It gives you some ideas how to tune it with some calculations. You can look at them later, and they're also on the Histrix wiki page, which has a very good documentation. For HTTP clients, there's not a lot of advice on that, and what we've seen is that people, certainly the connect timeout is often misunderstood. It's often really high on a second, or maybe even 5 seconds. But the connect timeout is the time you need to connect to a system, not to wait for its answer. So within your own network, it should be really fast, maybe even sub-millisecond. Well, I advise 100 milliseconds, which is really already absurd in itself, but don't set it to seconds. And if you're going to external networks, it depends. You should measure it and decide based on those measurements what a good setting would be. And for the second timeout, if you're not using retries, set it to the equal of the command timeout. And if you're using retries and you're only using one, then you can use the 99.5 resource latency plus, I always forget to fix this one, plus the median resource latency, and then it should be fine. Okay, operations. So when you're having this running in this production, then expect jitters and failures. They're really normal. Things that can happen is garbage collection, or maybe a new machine is starting up and it needs to warm up, so it's a bit slow at the beginning. But it can also be that your service has different payload sizes, and that causes problems. Or you have bursty call patterns where your backend system just can't handle it. And for instance, here is one of our most busiest services. Maybe a bit hard to see, but we see here peaks of about 250,000 requests every 30 seconds. And of those, in those 30 seconds, it could have about 250 timeouts, which is in the end nothing with the number of calls you're doing. It's really a small percentage. And this is fine. We're not trying to fix this. It's not really to fix. But when Hystrix is reporting failures in the sense of high error percentages or circuit breakers open up, don't overreact by trying to reconfigure the system immediately, because it can do that dynamically. But first try to figure out what is going on. Check the backend system if it isn't to blame. And if you know what the problem is and it's still failing, then you probably should try to retune your commands. But it could simply be that Hystrix is doing its job. So some general experiences we had at BulletCon with implementing it. Since we use it since last year, it already prevented a lot of small outages, which is still painful, but also a couple of really big ones, which we're really happy that we had this in place. And because of that, especially our operations guys, because they do the night stuff, they sleep a lot better. It's really good, because you don't want them grumpy. And in the end, well, Hystrix is, to be honest, becoming a little bit aged with some features it doesn't have. But in the end, it still does a really good job, and it integrates well, at least with our tooling. And it's really pluggable, so it should integrate with your tooling as well. And it's fairly easy to learn and implement, except for the tuning part, which has a learning curve. So it's also often overlooked. We notice that we need to always check that people do it. And it's, like I said, it has a learning curve. What you get is incorrect timeouts and thread pool sizes, which often isn't really a problem, but if you have a high traffic service, this is crucial to get it right. And those clients, they're often forgotten. In the end, I think for us it was more of an organizational challenge to get it done, because we have many teams working on one web shop. We have many services there as well, and you need everybody on the same on the same level that they really want to implement this, from IT management to business to my colleagues, to get this done. But we, in the end, we made it work, and our webshop is really resilient now. So, but I think this is one for everyone that's going to be difficult to get it implemented everywhere. So to wrap up, failures not the exception. They are normal, so we need to be resilient. And some things you can do is implement fallbacks where possible, even if it's just decent exception handling. Manage your timeouts really carefully. Use bulkheading and load shedding to prevent resource hijacking. And use circuit breakers to skip those futile calls to systems of which you know that are unhealthy in any case. And it doesn't really need to be that hard from a technical perspective, at least, with libraries like Hystrix. So, that's it. Questions? Yes?
Before going with Hystrix, you guys probably did some POCs and decided to go with Hystrix.
Yeah.
So can you talk a little bit about the pros and cons between Hystrix and the competitors?
So when we started implementing, there weren't. Oh, sorry. So the question was, how was our process of choosing for Hystrix?
Yeah.
Yeah. So in 1.5 years ago, when we started with this, there weren't a lot of really competitors to Hystrix in the market. There are some other circuit breakers, but that doesn't really offer the whole integration with our monitoring and backend and backend systems. So for us, it was we didn't really try out a lot of different solutions. We really liked Hystrix and what it tried to do. We piloted it, and it really worked well for us. And from there on, we went forward. So yeah, that was really simple process actually, yeah, in that sense. Other questions? Yes.
I've got two actually. I'm going to cheat a bit. One really quick one. Do they have a timeline for when they're going to support newer versions of ArcGIS?
So the question is, do the Hystrix guys have a timeline when they want to support the new ArcGIS? I don't know. Hystrix 2 branch exists for, I think, more than a year now, and there's not really happening a lot. And that's actually the biggest drawback of Hystrix currently, because Netflix, although they seem to be going forward with Hystrix 1, it's more maintenance than, you know, trying to set up the whole new thing. So yeah, it's a pity, but okay.
Yeah, interesting. Yeah, so my real question was, who's watching the dashboards in Bol? Is that the developers, or do you have a separate team, or how do you organize this?
We have both. So we have these screens at every desk, and they show different kinds of monitoring information, also that dashboard, but also we have this overview of alerts coming in, which is also tied to Hystrix. So when circuit breakers open, these alerts get in, and they will also result into SMS text messages when something is really wrong. But we also have an operation team which mostly does things at night. It's actually site reliability teams, to be honest, and they get awakened by the SMS at night when something goes wrong.
Can you share how often this happens?
Not a lot. The last time it happened was a couple of weeks ago, and it was because not actually because of a problem, but some weird situation where a circuit breaker opened which it shouldn't have. But it was something that we did wrong, not something that Hystrix did wrong. So no, it doesn't really happen not a lot, at night at least, because often it's some service restarting or doing an upgrade that's causing the most of the problems, and those happen during office times. And then it's the team that will respond to the problem, and will simply ask the other team, "Hey guys, what's going on?" And then yeah, we're doing this, and then oh, okay, fine. So okay, anyway. So to the back.
Is installed on the client side, right? To be the system between the client and the server.
Yeah.
However, nowadays the client is usually multiple machines. So how does it work in the case of distributed clients, especially when they scale up and down? One question. And second question, how does it handle the consensus while coupled servers, coupled clients still at stop, coupled clients still at latency? How you can get this collective dashboard?
So the question is, how does it work in a distributed system when you have multiple instances and Hystrix is on the client side? So how does it deal with that, and how does it create a consensus when some fail and some don't? Right? Yeah. Okay. So it doesn't deal with the consensus part of it. Every instance just has a view for itself, and these metrics that we see when I go back a bit, this one here, you see we have this host number and this cluster number. So this number is the number of requests coming in from the cluster. It's just that every instance sends out its metrics. It gets into this service that counts everything up, and that's it. That's the only thing that it does to give you an overview of your whole cluster. In the end, every instance needs to figure out for itself that something is going wrong or not. And what can happen in that case is that some services will have actually open circuit breakers and others don't. And that's just how it currently is. And we don't really have any issues with that. It's fine. You know, you still need to deal with the actual problem in the back end in the end. So, yeah.
I'm curious about timeout management. Like if you have 30 services that depend on another service, and you've originally configured your timeout for that service
Yeah.
for 1 second.
Yeah.
You have to update it to 2 seconds or whatever.
Yeah.
How do you distribute the shared config? Is it like a backing data store or a config file that you distribute?
Yeah, so that's the question is, how do you distribute configuration if multiple instances have a certain timeout setting? Well, that's something out of sight of Hystrix, to be honest. But we at Bol.com, we have this configuration system called, well, it's Kevlar is an internal thing, which just stores the properties for every service. And when you want to update a setting, you just go to Kevlar, go to your system, update that property, and depending on how you set up your system, you need to do a restart, or your system will automatically pick up the setting and will apply it. So because it will pull the backing store with the configuration every so many seconds. Yeah, but Hystrix itself allows you to do these dynamic changes at least. So that's really cool. Any other questions? Yeah, the man in blue.
So we were talking a lot about client side determining like what is acceptable, what is not.
Mhm.
So what do you do on the server side? So do you have sort of a normalized sort of a default response rate, and then saying that if it takes longer than 50 milliseconds, I just cut it off, like for every client request, whatever, or do you just let the client decide, like if it's a second, that's still fine?
Yeah, that's so the question is, what do you do? So this protects your client against the server. How do you protect the server against the client?
Yeah.
Yeah. So to be honest, we're still sort of in the beginning stage of implementing that, because what you want to prevent is clients sending too many requests to your backend. Well, some services use, how they are called? It's like the rate limiters. Yeah, they use the rate limiters to simply limit the amount of requests they accept. And then if it's too much, that could be because of latency, because then more requests start hanging around. It simply will cut it off and send a certain HTTP error request back to the client, which will then have an error itself, which could cause a circuit breaker to trigger, which could cause the backend system to be relieved of that traffic. Yeah. But that's another case of resilience you should be applying at the start of your application. Yeah, but Hystrix doesn't really do anything for you in that case. You would need to implement some other rate limiter.
Did you use Hystrix like as sort of a in-between proxy?
In theory, you could, because you could put everything behind Hystrix if you want to. You could put it in front of your resource and simply let everything go through. But I personally haven't really tried that yet, but it would be interesting. Yeah.
I can jump in.
Okay.
Right, cool. Yeah, thank you so much for doing your presentation. I like how you did your Q&A with your and yeah, we're now going to go for let's say a 10-minute break. It's 8:03. Pizza is running late. That is not good. So it should turn up at 9, maybe 10 past 9. So hence, well, we can have a long break now. Get some more beers, get in snacks so you don't die, and yeah, see you in a bit. You're still here, so that's great. Second speaker of the night is Stewart.
Sjoerd, yes.
Stewart. It's like it's.
You can
anyway.
just forget about the J.
Yeah, it's just hi. Who's come all the way from Picnic, and yeah, going to talk about Meso Services.
Yeah, mysterious.
Yes, it is.
All the way from Picnic. I just walked here 15 minutes. We're
There we go.
we're
Really
quite close.
That's great.
Yeah, so I'll tell just a tiny bit about myself, and then a lot about Picnic.
And I'm going to leave. Can we give him a warm welcome?
Right, so just to introduce myself, I'm Sjoerd. I'm officially called software architect at Picnic, but we're a startup, so we're basically all developers. Yeah, I spent today replacing our security system, so we made a bet on Stormpath. I don't know if anyone heard of Stormpath as an identity provider. We do everything in the cloud, so also our identity provider was in the cloud, and we got a notification. We got taken over by another company, and we're stopping all our services. Good luck with it. So yeah, that was a big project. Yeah, that's what my day looks like. Lots of development, but also very nosy and looking into what other people are doing to make sure that all the services we are developing are working together in a proper way. Right, so first slide I have here is one with a lot of text on it for my normal standards, and that's because this was actually the title of the talk, all this together, that I gave a code motion. It's actually our CTO who came up with this title. So I thought I'd just get a whole slide for this to just explain what the title is about. So first of all, it says Meso Services, which hints that we might be talking about something like microservices. We're going to talk about microservices. We're not doing microservices, but we're going to talk about them. And it says architecture for optimal trade-off between engineering and operations efficiency. You could have probably, thought of a shorter title for that, but it does kind of get to the point where I want to be, which is that microservices have a lot of advantages, also a lot of disadvantages. You get a lot of talk at the moment. If you just search for microservices, you'll get blogs about how you have to do microservices, blogs about how you should not do microservices, but there's not really a middle ground, and what we are looking for is exactly that middle ground, and that's why I want to let this talk be about, just focusing on that middle ground. Is there anything in between there? So that's how we came up with Meso Services, because my CTO asked me and said, we're a trendy new company, you should be doing microservices, right? So I said, yeah, sure, we should be doing microservices. Right, so we are doing microservices, right? Because I want to sign into this talk at this conference, and it's about microservices. Not really. But by the time you're going to give the talk, it's only in 3 months. We'll be doing microservices, right? Define microservices. And that's really what it's about. So what is a definition of a microservice? It's completely undefined. If you look on the internet, there's lots and lots of different definitions. And the most accurate definition is that it's pretty much whatever you want it to be, as long as it has a very nice interface, has fairly local storage, but it doesn't say anything about size. You can have a microservice that's 20 lines of code. You can have one that's 10,000 lines of code. According to most definitions, you could still fit that in somewhere. So yeah, it's already a bit of a fuzzy concept to begin with, and what we are working towards is using an even more fuzzy concept within Picnic, and that's with a reason. So what I want to do in this talk is give you a bit of background what we're doing, and then just tell you how we are approaching it and what kind of challenges we have, and hopefully get some interesting talk going as well. So yeah, I found this a couple of months ago by now, I think, on XKCD. I thought it was quite relevant to a lot of, the more inspirational talks. There's a lot of people saying this is the new paradigm for whatever. You can think of anything. Or we did it this way and it worked perfectly for us. So microservices is a very good example of this. There's quite a lot of talks on the internet about people explaining how perfect microservices were for them. But they do kind of fit into this picture where you must take into account that you only hear the guys talking who actually did this successfully. There will also have been, for every talk that proclaims microservices as your new perfect go-to architecture, there will have been 10 people who completely failed at it and just left it alone. So I'm going to present something here as well, and I would really advise you to take that with a big grain of salt and think about, what does that actually mean for me? So does this even apply to us, or are we a completely different company? Right, microservices. Yeah, when we started as Picnic, that was 2 years ago, nobody really had time to think about a real architecture. There was this idea that, you know, we need microservices because that's probably where we're heading. If we're looking at all the blogs, then this is probably where we're going to go. Turns out to be pretty accurate. But they needed to get a shop running, and what we do is we do groceries. So what is Picnic? It's very simple. I'm going to just skip to the next slide because I'm going to see this one at least 3 times over. This is actually the core of the talk. So if you just remember this picture, I'm going to be so happy. So what's Picnic? This is Picnic. What we want you to do is not go grocery shopping. What we want you to do is just think about your groceries and they magically appear in front of your nose. Now, we have asked around a bit at our big technological partners, so yeah, it turns out that yeah, teleportation isn't quite there yet. Mind reading, yeah, we're getting there, you know. I hear that some projects running at Tesla. But yeah, we're not there yet, and we just want to make it as close as possible. So what have we done in actuality? Well, you still have this bloody app that you have to navigate, so, you know, but that's already better than actually going to a physical store and browsing around and figuring out that this is not actually the chopped tomatoes, but this is the whole ones, and you only find out when you got it home, etc. So we have some apps, and you just order and we deliver at home. That's the best we can do at the moment. So we still have this whole physical process, but we completely hide it from you. You don't have to go to the shop yourself anymore. Just as a general question, who's heard of Picnic before? Ah, that's nice. We have a little bit of name spreading going on. That's good. Who's ordered with Picnic before?
That's not possible.
You have actually ordered, or do you have a question?
Is this the Netherlands Instacart? Popular?
It's not quite the same. I'll get to that. I'll explain a bit more about how we are organized, and you'll see that so Instacart, I think, doesn't do the delivery themselves, right?
They hire shop.
Yeah, yeah. So I'll get to it, and you'll see exactly what the difference is. Yeah. So anyone who ordered? Yes, great. So we have market penetration. Perfect. And yeah, no, it's nice. About half a year ago, we could just talk about Picnic. Nobody would have heard of us, but this is actually going somewhere. So that's good to hear. Right, so this is what we think Picnic is not. So this is a normal supermarket. So say Albert Heijn, Jumbo, they look a bit like this. You get suppliers on one end, so we have a nice farmer and a baker and whatever we got. They bring their stuff to some kind of warehouse somewhere. Big warehouse, that's where everything comes in. Then you have lots of brick buildings where you just put all your goods and show them to people. And then everyone from their home takes their car to the supermarket, goes shopping, takes the car back, and you know, this is what we are trying to avoid here. So there's a couple of things wrong with it. You can all imagine what we don't like about this. This is what we want to do with Picnic. We have some apps here. We do still have this big warehouse, so we do still get our stuff in somewhere, but then we cut out all the brick buildings in the middle, and we do our own delivery. And we do it in such a way that we use what we call the bus model. So we plan our routes in fixed areas. So we let people in our shop in fixed areas. We let them order at given moments. So we give you 3 options in a week or 6 options in a week to choose from. You say, okay, I want to have my groceries tomorrow at 6, or maybe if that's not convenient for you, then the next option is the day after, but then at 5 o'clock. You choose your slot, and then we just, for every slot, make a route planning and try to basically keep as dense trips as possible. So this is going to really cut down on our delivery times in the end. So we spend a lot less time per delivery than say Albert Heijn, who basically go to random addresses without actually planning the route in advance. Well, they do some planning, of course, but they get a lot more more varied input basically. So yeah, it's a lot harder to get this efficient. You get longer drop times, longer drive times. That's where we're trying to cut corners here. So yeah, let me restart that. What we're trying to do here is give you Albert Heijn quality for a jumbo price and delivered for free at home. That's the concept. So the one guy who ordered, what's your experience? Do we?
Actually quite happy with the product and the service.
Good stuff. Good stuff. So yeah, we. Yeah, our main focus right now is just quality and keeping everyone happy, of course. So what I want to give you a bit of an impression of is the type of systems that we have, because what is different about us, if you compare us to other web shops, other supermarkets, is that this whole trajectory in between is all under our control. And that's where we think, A, we have an advantage, and B, it makes it a lot more interesting than any other shop, for techies like us, at least, because we have this whole world of data that we can just interconnect, and anything that happens here, we actually could feed that back all the way back to here to make sure that we optimize processes here based on what's going on here, and the other way around. If we see that something is out of stock, we can immediately start spreading this to the front end. If one of our suppliers says, well, we have some really local suppliers, so we have in Amersfoort Sambal Bert. He sells sambal and nothing else. It's great. He's a nice guy, just comes in with boxes of sambal and we just sell them on. If he says, I'm sick, I can't make it tomorrow, we just immediately are able to update the store. There's no big data transfer processes in the background. We don't have to do transfers between a lot of third-party systems to get this to work. It's all under our control, and that's what makes this exciting, and what makes it a bit more complicated as well. So our systems, we have a gateway. The gateway is basically intended to just give a REST API for our clients. There's vehicle routing, so we actually do the routing of our vehicles ourselves. There was an intern who came up with a routing algorithm that performed better than the one we were using from a third-party tool, so we're actually doing the third-party tool out now, which is pretty cool actually. Nice stuff to work on. Distribution planning. So yeah, actually making sure that we actually get the orders in the right places on time to start your routes. And then from the other side, we have purchasing. So we do automated purchase orders, because you can't just have some guy, poor guy, just keep writing purchase orders all day and just doing it manually. So you just have order prediction. Lots of stuff gets generated and basically sent automatically. Some stuff is still held back for manual checks, and then we just approve it and it goes out. That's purchasing, is growing and growing as well. Lots and lots more features, because you want to do better prediction. You want to make sure that you don't over order. You want to make sure that you don't waste too much in your FCs by over ordering or under ordering. When you have done your purchasing, you will get stuff in your warehouse. At least that is what usually happens. If you place an order, you will get some stuff. So you need to be able to receive it. You need to be able to put it on locations. You need to be able to pick it. You need to be able to pick stuff in totes for certain customers, put them in the right frame locations, get the frames all in the truck. We ship the trucks to hubs. From the hubs, the frames are put in small delivery vehicles, and then still everything needs to be in the right place for the delivery guy to just be able to do their rounds the way we planned them in the beginning. So again, lots and lots of data integration there. Super exciting stuff if you get into it. Apart from that, we also have the normal basic stuff. So we have a bunch of users that we have in our system. We need to do some communication with our customers. We need to keep track of our orders. We need to know how much stock we have and how much stock we are going to have in 3 days' time, because people are ordering for at least, well, at most 2 weeks ahead, and at least 1 day ahead. Yeah, so we have this algorithm, small service, which is just calculating for every day how much stock will we have of this product at that given time, given that we already have so many orders and we have ordered this much extra in and we have this many products expiring at these dates, etc. Catalog management, what do we actually sell, finance, and then a whole bunch of other, yeah, more cross-cutting things like pricing. We have lots of Slack integration. We try to keep everything on Slack for our company messengers. Super nice. We report basically the most serious errors directly in Slack to the relevant teams, and that works pretty nice actually for a startup. So that's good tip. Use Slack integration. Right. So given this landscape, first thing you think if you look at the architecture, or if you look at what could be a good architecture for this, is, well, we have a lot of different services. They all seem pretty isolated, so they have their own domains. You know, why not go for microservices? Because you get isolation of your different services, so you can also contain errors better. You get scalability. You can start doing continuous deployment, even if you wanted to. Technology stack you can choose freely for every different service. Don't do this, by the way. And you can move fast at a large scale. So this sounds really nice. I definitely pitched this at one point to our CTO, and he also thought this sounded nice. I see my battery is running out, so maybe we'll have to have a, but we'll see how we're going. So yeah, the question arises, are we in fact a sort of Netflix? So yeah, not quite. So if I compare the numbers, so Netflix started doing microservices, from the top of my head, 2000, I have to cut through this. I have this in my notes. Wait, let me just check. It's not showing my notes. Never mind. 2000, early 2000, somewhere. If you look back into their report, I think they had a revenue of a couple of billion. They probably had a larger software development team than we do. We have 20 backend developers, sort of. Depends who you're counting. Some people are in more than one team. So yeah, I don't know. I don't think we're not quite Netflix yet. So does this actually fit us? And this is where we get to this picture again. So glad I'm back here again. If you look on the internet now, you get a lot of people saying, as a small company, you should just start with a monolith. It's easy, you get fast development. With a small team, it's super easy to just keep the overview, because if you have just 5 people in a room, you just keep hacking on the same stuff. Everyone knows what everyone else is doing. It's basically how we started as well, except that there were some people in the company who already thought about microservices, and we are so thankful that they did this. And this begs the question, so if you start with a monolith, how are you ever going to get to microservices? And that's something that I'm really missing in any advice that you see on the internet. There's lots of blog posts saying you have to go for microservices, which basically is suggesting for any company to just make a big bang move to microservices, which is a really, really bad idea, because you get so much extra trouble, and it's just not worth it. Or you start with a monolith, but then you end up with a monolith, and nobody wants a monolith, because in the end you want to be here. So how do you get from here to here, and how do you make sure that all along the road you are still happy with what you actually got? Because there is no blog post in the world that will tell you that this is a good place to be. Everyone will tell you, you need this or you need this, but somewhere in the middle, out of the question. For us, if we look at what we need, and I'm just going to try and speed this up a bit. Well, if you separate everything, you have 5 different services instead of one thing that is doing all that stuff combined. You get a lot of overhead. It's inevitable You need to define interfaces between the services. You probably need to start thinking about, okay, does this service actually think about this domain concept in the same way as this other service? So maybe you actually have one concept like an order or a customer that actually has a different representation in one service than in the other. And then you're very tempted to start combining that, but that's not through microservices anymore. So yeah, you get a lot of overhead. Good stuff. I have no idea.
It's coming back. It's coming back.
Right. Continuous development, lots and lots of investment in actual infrastructure to get this to work, right? I mean, if you can just deploy your entire application with 2 clicks of a button, don't think about continuous deployment yet. We have another speaker in the back of the room. Yeah, so then there's this saying, microservices. What is microservice? Well, you do one thing and you do it really, really well. Now that is perfect advice, but you have to know what thing you are doing really well. Who of you has ever built a supermarket from scratch?
Oh.
No? Yeah, well, we also never did this before, so we had no idea. I mean, what does it even mean to start a supermarket? We're still finding out. We're scaling out to different cities now, to multiple warehouses, and every step you take, you just find new surprises, and you find out that everything you thought was true about a certain service or a certain area of expertise actually is not quite accurate, and you need to completely overhaul your model, the way you think about stuff. It can just change, and we're slowly stabilizing now, but we're now going to see about international expansion maybe, and that brings a lot of other surprises, like, oh yeah, we let people register with a postcode. Huh, that's cool, that works in the Netherlands, but how about the rest of Europe? And it turns out that postcodes are not that universal. Yeah, so that's just a small example. Things change, you don't know what you're doing yet, so if you start encapsulating this in all tiny services at the beginning, you're going to make some really big mistakes, and then refactoring that is going to be a lot more work than refactoring your monolith. Then company structure. If you look at the ideal structure for microservices, you just have a lot of services, and every service has a small team assigned to it. Where's Maurice? Ha, Maurice, how's this at Bol?
We still have a couple of monoliths around, and it takes a long time to tear them to pieces to make microservices.
Do you have the capacity to make them all separate teams? Could you do this with your current work? One team is multiple. Wow, that. Yeah. So, and that is for a company with 315, if I remember correctly from the slide, employees. We're with 20. We have a lot more systems than we actually have people. Yeah, we can't do this. We can't have dedicated teams on microservices, which means if everyone is doing every service, then de facto you're basically building a distributed monolith, because everyone's going to push the boundaries about, you know, what's going to be this interface in between these two services. Oh, we can sneak this in because you know, I'm also working on that service, so I don't care. And before you know it, you don't really have microservices anymore. So yeah, and then variation technology for a company our size, it just doesn't make sense. We want to have a shared stack. We want to actually have a pretty default stack as well, so we can actually hire people. By the way, we're hiring. Really, we're hiring. We would like to be able to hire from a pool that exists. We don't want to start a lot of stuff in, I don't know what trendy language we. Shh. Right, so this is basically what I'm trying to say. We're a small team. For us, time to market is everything. That's the only thing we really care about at the moment, because if we don't get there in time, there's no point in getting there at all. We have so many different disciplines that we have actually no idea how to structure these microservices yet. We just need to grow so that we get different teams first, and then let the software architecture follow the organization instead of the other way around. And operations efficiency is also a big thing. I mean, every customer that we say we're going to deliver your groceries tomorrow, if we don't deliver them, they're going to be really disappointed. That breaks down our brand in a way that we cannot imagine. So what we need to do is anything we promise, we need to keep that going. We can't afford to shrink. So anything you do, any scale up you do, you need to be able to sustain that. And whatever big plans you have in the architecture, if that means that you're going to stop your growth, it's off the table. We're just not going to do it. Yeah, so that's why we're not doing microservices yet. But yeah, what I'm just projecting here a couple of years in the future. I don't know how many years. I'm not going to make any bets on that. But we want to be this innovation leader. I mean, if you look at what we're doing now already, there's some pretty cool stuff going on. The fact that we do this entire chain ourselves, that's something that no other company is doing. The fact that in our warehouses you can just look up at the dashboard and see how much is picked and how far we are in the percentages. There's people coming in from other countries just walking in our warehouse going, that takes about a day for us in order to give a report on what you're showing here live. That's the kind of stuff that we really live for. We want to just keep pushing this and see how efficient we can get this. Hopefully, we will have many small teams, and that would fit perfectly with microservices. That would mean that a lot of you will have to apply for a job at Picnic. Even more disciplines. We are also pulling in-house lots and lots of external party systems simply because we see that they don't quite fit our requirements, or we cannot quite get the optimizations out of there that we would like. So one example is the warehouse management system. We didn't really intend to do our own warehouse management, but by the time we got to the restrictions of our current system, we just saw no other option. The only thing we could do to grow is just build our own. So we started on that, and we're still not finished. We still have 2 warehouse management systems now. One is still doing some tasks. The other, our own build system, is taking over more and more. But yeah, we need to pull some stuff in-house, which means that we're going to grow in the number of disciplines as well. And eventually, we hope that we know what we're doing. And I think when that time comes, then we're ready for microservices. That's the point that we know that we can split up this monolith and not have to touch all those interfaces every day. That's the moment that we know that if we have a dedicated team working on this service, they can push that service to the next level without affecting the other services. Until that time, there's no point in going there. So yeah, you know, maybe one day we can compare ourselves to Netflix. I'm gonna skip the long-term plans and skip a little bit towards our very, very brief history. So we started out in July 2014. I wasn't part of Picnic then. I joined somewhere here, I think. And this started out with a standard stack. We're using Spring, Spring MVC, Spring Boot. We're not using the Spring Boot server that comes with it. We're actually deploying web apps in Tomcat. That's because we're using Amazon Web Services. A lot of the people in our company actually come from a different company called Threadhopper, and those guys knew how to use Elastic Beanstalk, and they thought, let's just go for that because we know how to use it. Perfectly fine choice. We're moving away from that now. So yeah, Spring, Amazon Web Services, we have Jira. We used to have lots more products from them, but moved away from that as well. Choice was made for Mongo. I get a few questions about that. How is Mongo in practice? How did you like it? Nah, it's okay. It works. In some situations works perfectly. Some situations you should just not go there. Rather few for our messaging. At some point we migrated from Bitbucket to GitHub, then Travis came in, so we actually are doing some automated builds, automated deployments even, but only in development. We don't want to do this to production yet because we don't trust it. Then we start building our own warehouse management system. Yes.
Don't you have a cache solution?
A cache solution. Yeah, we introduced that here. I didn't mention it because we're trying to get rid of this as much as possible because we see that the performance of caches and versus performance of MongoDB, we can actually get away with usually just using MongoDB instead, or using in-memory caches, and then we're fine. Distributed caches are nice, but they can be a real pain to get rid of. So if you do rolling deployments and you have something to migrate in your cache, that's something to think about. Yeah, so we started building our WMS, then we thought, okay, WMS, we need to get some stock from one place to another, which means that we actually want to subtract stuff here and then add it there, and then at the end still have the same amount. Transactions could be nice. Mongo doesn't have them. We'll introduce Postgres. So we got extra techniques there. Then we started introducing now RxJava. We are actually looking into starting to use Hystrix as well. So I might be contacting you again. We're currently also looking into moving away from Amazon Web Services from Elastic Beanstalk. We're definitely staying with Amazon right now for our service, but we are looking into actually Dockerizing everything and getting everything deployed through Kubernetes instead. I don't smell pizzas yet, right?
No, it's fine.
Good. So yeah, once we have all this, again, then we might have a technology stack that would be ready to start thinking about real, true microservices. But this is one of the things that you must have. You need to have a nice deployment, nice way of deployment. You need to have, well, either blue-green deployments or canary testing or something like that in place in order to get the full benefit of doing microservices. So yeah, this is basically where we're going. We're trying to figure out what techniques we use, what we need to use. Try to keep it fairly limited in the Java space, everything. We are expanding a little bit into Python now because sometimes that's just easier. But yeah, we're not really going into really fancy projects with obscure programming languages that we can find 2 developers for in the entire world yet. That might come when we do this. Because then we can simply say, okay, this is a nice project of 20 lines of code. We'll just spin up a new instance somewhere, and we don't care about this. At the moment, we still have to care too much about what that does to our deployment and whether we can support this, etc., etc. So, yeah, we're kind of banning that for now, but this is the future we would like to see. Then, tiny bit of history. I thought you might enjoy this as techies. I just included this for people who wanted to have a bit of an idea of what Picnic does on a daily basis. Yeah, so this is the first architecture that was ever drawn. It's literally just this. This is the only thing I could find. There's just one picture. There's lots of systems on there that actually don't really exist. It's just basically mind mapping from the first people who started coding. And they obviously just drew this down with the idea we're going to make a layered model. There's no microservices in here, as far as I can distinguish, except that we have these components over there. And they were wise enough to make these already communicate over REST interfaces. So basically, we have a lot of interfaces that are deployed on the same machine, but just communicate over REST, over localhost. The moment we want to put them somewhere else, we can quite easily grab them out, put them in a different deployment, and just spin them up elsewhere. And the only thing we have to do is reconfigure the URL that you're going to use as a client. I think that's one of the things that they did really well. If you look at this, it's not much of an architecture. It's a layered model, but it's not even clear why these layers are exactly like this. Maybe this should have been multiple layers. If you start thinking about the components in here, there's a lot to discuss. But what they did really well was thinking, okay, let's not overthink stuff. Right now, all we need is 3 deployments. That's basically what we had. This is 1 deployment in AWS. This is a second. This is a third. That's got everything we need for now, and let's just make sure that the interfaces here are, as crisp as we can get them. That's helped us a lot. So by now, we've moved out some stuff. So keep an eye on these 3 layers. This is called Gateway, so that's the one that's actually providing the REST API to our clients. This one was called Data Layer, and this one is called Fulfillment. Now I'm going to give you the overview of our current deployments. So this is just deployment structure of Picnic at the moment. We may have gained or lost 1 or 2, but yeah, this is approximately it. This is still Gateway, this is Data Layer, and this is Fulfillment. The Data Layer now has been split up into Data Layer, and for every FC that we have, so every fulfillment center, we have a separate deployment still. And this was a lot easier to do than we thought initially, simply because they thought at the beginning to actually separate the interfaces. So we we pulled out a couple of services, put them on a different deployment. Now I have 2 copies of this running because we have 2 FCs. For every FC we just spin up a separate copy, and we were good to go. This is not microservices because there's lots of different subjects in here. There's a category management here, catalog management, sorry, ranking service, search service, let's see, shopping cart. So there's lots of services that you could really see working as a completely separate service. You could deploy them separately. You could give them a super nice REST API. We just don't do this yet because we don't know if it's going to change. Yeah, all these on the side, we didn't know about when we started that we were going to need them. We have a separate executor for some batch jobs. We don't have a really fancy batch job infrastructure yet. We're going to go there once we have Kubernetes. We want to do all kinds of fancy stuff. But yeah, right now we don't have anything really fancy. We just have some node that's spun up that does batch jobs. And you can submit jobs to our ETL processes and they will execute them for you. There's actually a cron server somewhere. I mean, this is not new technology, let's put it that way, but it's just easy to have. Analytics, we didn't do analytics in the beginning. There was a prototype that was created in about, I think, 9 months. Then they went live with it, and they just had these 3 and started running with it. From there on, we added lots and lots of different services. This has probably increased in size about 10-fold in the time that we started developing and started going live with our Picnic brand. So before we did a tiny test round with a brand called Sprinter. That was the time that we did like 10 orders a day. We've scaled up so much since then, and everything has grown around it that, yeah, you can't really compare this system anymore to the way it was. But if you look and compare the old picture with the new picture, you can see that slowly we're tearing things apart. We get a few more technologies, but in the end where we're going is more and more separate little blocks and then just putting them all somewhere in Kubernetes and try not to think about it anymore. That's the dream. Okay, so what's micro about this? Well, we still have separation of concerns. We are designing API first. We do messaging and HTTP, so we actually have we do our push communication through routing queue, and all our pull communication goes over HTTP REST with just plain JSON in between for all the services. There are people who are claiming now that this is not very microservices doing REST interfaces because it's not very decoupled. This might be true, but I can tell you that messaging is a pain to debug. If you can keep it simple by just having some synchronous endpoints and you don't need all this asynchronicity and you don't need all the performance, this is really nice because you can just go to a server, type in the URL, do a curl command and see what comes out. And if it doesn't match your expectations, you have a good starting point. If you have to do that through triggering some kind of system, then getting it off a message bus, trying to figure out which threads have been running to create that message, etc., is a lot harder to debug. So again, we're trying to steer clear from anything that could prevent us from growing really fast. Yeah, collection per service, we already have this. This came super naturally. If you look at microservice architectures, they all say, okay, you just have one thing and you do it well. It means you also have one kind of data realm that you are the boss of as your service, and that usually means you have kind of one table or at least one collection in Mongo, so nested table structure, and that's it. If you look at our services, they all have only one collection, simply because if you just design your normal software without thinking about network boundaries, just thinking about how you structure your code, how you structure your, well, we use Maven, so your Maven modules in this case, structure your code inside there, your Java packages, your interfaces. If you do this well, you'll figure out that very soon you have created microservices, just not with a network boundary in between. So the only thing we did there is basically try and get those interfaces crisp and make sure that at some point we can pull them apart without too much trouble. So what's not micro about what we're doing? Multiple service per deployment. We just package a whole lot of shit together, spin it up, and it works. We don't need this to be deployed in 10 different services. It just gives us 10 times the overhead. So instead, we just package 10 services together, put actually in one web app, so it's really one executable that's running. We spin that up, and that's just easier to maintain. We do a weekly release. We don't do continuous releases because we don't have any use for it. Right now, just having a weekly release gives us a really nice cycle. Still really fast. If you look at customer complaints coming in, the fact that they are just definitely going to be fixed within a week. We sometimes do intermediate deployments, of course, for hot fixes, but within a week, stuff just gets through. Yeah, that's good enough for us right now. Then the limited tech stack, as I said, that's the only option for us right now. Then there's some things that we're not quite clear about yet. Who owns data? The moment you go from monolith, where the monolith obviously owns everything, so there's no question there, to microservices, the biggest challenge that we have now is figuring out which data is actually owned by which service. So who's going to have the end say in what the actual state of a certain object is. The orders, for instance, there's lots of attributes of an order that can change due to different services acting on an order. So if someone, I don't know, someone gets an order delivered and they see that they have a broken pack of milk and they tap in the app and say it's broken, comes back to our system, is registered on the order, but the system that is doing the registration is not going to be our order service. If you look at how this naturally evolves, you will see that the service that does the registration of the broken packs of milk will see more and more details of the order service slipping in. And at some point, it basically just becomes a monolith again. Splitting this up, figuring out where you have to draw the line and say this is definitely not the task of the order service anymore, that's super difficult. Then transactions, sometimes they're just really nice to have, but they don't fit with microservices models. Nothing is transactional, everything can fail. You have to just make sure that you can deal with this. But that also might mean that some problems you just will have to shield off from this whole microservices madness, because some things you just want to have transactional. Our payments, it's very nice, but we're never going to split that up into smaller components. One payment just needs to be handled transactionally so we know what's going on. The moment we have all kinds of failures and fallbacks in there that can make your process less predictable, it's just some domains don't lend themselves for it. So yeah, that's one of the things that we are still wondering about. So where do you draw the line? If any one of you has any experience or any interesting blogs or whatever to share, I'd be very happy to get some pointers. And then client libraries. Client libraries are the devil, in the sense that every microservice in our system currently will write its own client library for other people to import. You should not do this. And I see. However, it is super convenient the moment you know that these microservices are only used within your own application and are only used in the same tech stack, basically. So the fact that we are not going into all kinds of different programming languages means that we can actually have one client library that the moment that the service gets upgraded, the client library also gets upgraded because those people know what they were doing. For us, this is still an advantage. We know that the moment that we go to different technologies, this is not going to scale very well. But yeah, it's too tempting right now, so we're still doing this. Again, if you have some comments about this, I'd be very happy to have a discussion about this.
Generate your client.
But that doesn't work. So yeah, I'll give you a bit of background there. So of course we're generating clients in the sense that if we have a REST API somewhere, we try to just get an auto-generated client for this. But usually our client libraries actually do some caching, which is specific to the service usually. They might actually do some of the calculations on the client side instead of the server side, just because of certain bottlenecks somewhere. So there's a bit of logic in the clients as well. And the moment you get business logic inside a client, you actually want to have it in the same area. You want to keep the business logic in the same place. You don't want to spread that out to different services because you're just going to duplicate it. So we're still fighting a bit with that. We can make it, we can dumb it down, but then we're just shifting the problem again. And yeah, as long as we don't see a real good solution for this, we're currently just sticking with the client libraries. Sorry. Yeah, cool. That means that I should be at the end of the presentation, which I think is true. Yeah, so this is what we're doing, divide while conquering. We started out with this kind of monolith with people who thankfully thought a bit about where we were going. But along the way, we're splitting up, and we're just making a conscious decision to not split everything up all at once. So if we see a new problem, we're not going to spin up a new service and define a new API for this, and let every other service communicate over REST. We're just going to add it to one of the existing deployments as just a Java service. So in this case, in Spring, we just added a nice bean somewhere, and we talk to this. The moment we have a bit of a clue what this is going to do, then we start thinking about maybe we should separate this out better, or it might turn out that it actually isn't really a separate service, but is in fact two separate services, or maybe it's not a separate service because it actually belonged somewhere else that we already had, or we don't know. So yeah, we develop, and along the way we split off the things that we're sure about. When do you do this? When the domain is clear, so basically when you know what the hell you're doing. When there's a team available. If there's no team to actually look after a service, there's no point in splitting off the service. And when you actually need it to be there anyway, you're not going to just split off the service for fun. If it works as a monolith and you don't need extra feature requests, don't touch it. The moment you get into trouble because, for instance, you figure out that this one service is actually failing a lot and that big monolith is bringing down all the services together with it, then you have a good reason to start splitting it up. Then changes necessary, start doing it. Yeah, so that's basically how we are trying to keep happy somewhere in the middle of this monolith microservices space. I hope that some of this is kind of recognizable to you. I don't know how many of you work in e-commerce. Just show of hands. Oh, that's not too many. Wow. Where's the rest? Just a couple of you, for instance. Where? Anyone on the front row? Banks, I heard.
Healthcare.
Okay, yeah. Healthcare sounds like a domain where this could be a biggie as well. Yeah, so if anyone has experiences on this and knows how to deal with this middle ground here, please keep posting your stuff, because that's what's missing at the moment. It's what we are really missing. We would like to really scale up really fast with all those techniques that everyone already knows. Microservices are not new. We already know about this for years, and still there are no good guidelines on how to actually build something. There's only success stories from someone who has built something, but they never tell you how long they took. Yeah, finally, we are looking for many people, and I can tell you it's super fun to work with us. So yeah, if you want to join, have a look here. Don't go to ball.com. Come to us. That's it for me. So if you have any questions, I'd be happy. Well, since we're doing apps, yeah. Oh, yeah. Sorry. So did we ever consider Varnish as a caching solution? Varnish. Yeah. Yeah. I've only ever seen it used as a web page cache. So it doesn't really come natural to me to do this for our completely app-only stuff, because yeah, we just have REST interfaces which all carry no cache headers because they always change, and in between the different servers in the backend, I don't think it would. Yeah, I don't really see how it would fit, because we're mostly caching just real database structures and everything. So. Yeah, yeah, we're yeah. So yeah, for search results, this would actually make sense. I think currently we just don't do it because we don't need the cache yet. We don't have this performance issue yet. For all the services in our backend, we basically use local caching in memory, really specific to the service. So we just keep the entire data structure there. Yeah, we have looked into maybe looking into distributed caches, etc. for this, but it turns out that it's hard to get this working right in a way that you don't keep tweaking and tweaking for every different service. So yeah, for now we're just sticking with this. If you know of anything else that is easy to configure and will work for most situations, then keep me informed.
You can cache only your Java objects and keep track of that.
Yeah.
Most of the situation.
Yeah, but you still have this hit every time that you get something out of cache. Just the serialization, deserialization, and cache consistency protocols in between are actually pretty slow. If you look at that, then you might as well just do a hit on your database. If it's a simple database, it's going to be just as fast because it's still a hit to another server.
You mentioned that we try to follow the approach of component recollection, especially speaking about moment collection. So, in this regard, the question, so how do you connect the data from different connections, let's say customers to the orders, or classify orders and items in the customer base?
Yeah.
And secondly, how do you handle the organization? So, if, for example, you have customer collection in among orders or something like that, so how do you update this, let's say, consequently ready?
Right. So the question is basically how because we're using Mongo, which is basically document storage, so you don't really have any relational concepts. How do you deal with relations? And how do you keep the one-to-many relations updated? Is that
Yeah, how do you update the consequently modified data? Like if the customer needs one more order, do you
right? Yeah. So how do we deal with updates on data that changes a lot? Yeah. So you're probably steering here towards event-based, so event storage and trying to reconstruct stuff from your events. We don't do that anywhere. So this makes a lot of sense if basically if you have no other option. It's so much extra work to implement this and get it correct that right now for us it's so much easier to just do updates on the documents themselves. Mongo gives you not much in terms of synchronization primitives, but it does give you atomic updates on a single document, which in most use cases is going to be enough to implement anything in e-commerce land. There's very few problems that you need more than this, and if you do need it, then you can probably find a way around this to not need it, and that will greatly improve your life as a software developer. Event storage is super nice. We have one thing in place that looks a little bit like it, and we're trying to refactor this to a simple model just because we see that it's hard to tell. If you have to keep the entire history, for instance, when are you going to delete something? Your collection is going to grow and grow. How is this going to affect your performance? It's going to you get so many more questions there. We just don't want to take the risk with all those unknowns. We don't really have a use case for it. The moment we can still do it with conventional techniques, why not use the conventional techniques? If anyone here, by the way, has a suggestion why not, I would really love to hear it. Is anyone using event storage here? A little bit in Bol?
Just also discovering how useful it is, where we can use it.
Yeah, so I think for us that is a good indication that we're on the right track here. Given our company sizes, we'll follow your lead.
And one additional tip, if you want, on YouTube there is a talk called Monolith modular monoliths given a demo last year, which tells more about like your lines, how to develop your monolith in a modular way such that you get benefits if you.
Nice. I will get a link from you at the end of this. I haven't followed that one yet. Great.
Great. Well, I'm going to jump in. Thanks for doing your talk. Kind of
Thank you.
interesting. Yes. Hopefully pizza will be here like now. I'm going to send them like an angry phone call. It'll be like 50 people are starving, and hopefully it will be here very, very shortly. In the meantime, there is more beer and soft drinks and wine, and yeah, a few snacks you can fire over. And yes, all the pizzas. Cool. Thanks again. Really interesting.